Okay, we are continuing our class. So I connected my Wi-Fi, and through the same Wi-Fi my PLC is connected, and my PC is connected through the same Wi-Fi. Okay, so first I go there so that I can pair a communication between my PLC and my PC. I will click show, and my both PLCs are shown there. 12C DC 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 and 1215. Okay, then I click on show button. Okay, now so now we are going to my second PLC because I prepared my program there, and this is the main of second PLC, and this is the FC in which I prepared my Modbus program. Okay, so how I prepare, I will discuss from the starting. Okay, so this is the first Modbus communication load block. Okay, so in the Modbus communication load block, I have here the port button. Through the port button, you have to select here RS422 and 485 because I have this module CM 1241. This is CMS module, and here I write my baud rate and parity, and both these values should be same in the parameters of the drive. Okay, and now what should I do? Firstly I will tell you about the basics of the program. Okay, so now I have prepared this program for the run command. In the run command I have four buttons: the stop button, forward button, okay, and this is the reverse button, and this is a reset button, because when the drive whenever a fault occur in the drive, then the fault can be reset through this button. Okay, so I play so I take another block from there, and from we have a lot of block we can take from there, and one of the block is MB master, and in the MB master there are four things: MB master, MB address, mode, data address, and data length. Okay, so what is MB address? MB address is the slave ID. Okay, so the I write here 100, and that means there is some parameter in the drive which is known as slave ID, and I should both these values should be same. Like I write here 100, then at the parameter of the drive it should be 100, and it is a mode 1. Mode 1 means I'm using write performant through this. Okay, through if it is mode 1, that means I'm writing in this register, and this is the data address. Okay, so this is the data address. I am writing my holding register address 48193 because this is the address. Okay, and in this address I will write some values like 1, 18, 34, 8, and I send value 1 to this address, then the drive will stop. If I send 18 value to this address, then the drive start to move in the forward direction, and if I place 34 value in this register, then the drive start to run in the reverse direction, and if I place 88 in this address, then the if I if any fault occur in the drive, then the fault will be reset. Okay, so this is the significance of the data address, and this is data length. Data length actually is the size of 16 bit. Okay, so okay, now we are this is data pointer. What is data pointer? I want to write some value in this register address, then this value will be written to this address, and I will through the move block I have the same you can see the address like here. Like if I send 1 to this, 18 to this, all these are same. Okay, all these are same. Okay, so one by one I send the value there, and the value at this register I will change according to my need. Okay, so this is the run command to the drive. Okay, now I will tell you about how to change the speed of the drive. Okay, so in the speed of the drive, be careful here. I'm using one Modbus communication load block here. Okay, and I have to write it I have to write here MB master DB. Okay, so same db should be same MB master db should be there, like in the run command and in the frequency command. Or like if you want to read some data from the drive, then you can use the same MB master block. Okay, so this is important. Okay, so I write the same here as I write in the run command. Same is the slave id mode, because I want to write the frequency in the drive through the Modbus, so I write here 1. And it is a holding register address. At this address I will write the value of the frequency. Okay, and this is the I am writing my frequency there, and I multiplied, like I want to start my drive with this frequency of 24 hertz. Okay, so I have to provide here 240 value. Okay, like if I want to run my drive at 50 hertz frequency, then I have to provide here 500. Okay, that's why I multiply here by 10. Okay, and that value will be go there. Okay, so same, everything is same. Okay, now I want to check my at what frequency my currently my drive is running. So I check the address at which holding register address I am getting the output frequency from the drive. So I check it, and it is 48452. Okay, and its data length is 1, because 16 bit, because the data I am using here is 16 bit. And at this address, at this db address, I am getting my actual frequency, or you can say the output frequency of the drive, and I can use this value in somewhere in my program. Okay, so this is the RAM function which I previously told in my class. Okay, so now what we are going to do, we will run this program. Okay, and we will check everything. Okay, we will reverse, we will forward, and we will stop our drive. We will reset our drive, and we will change the frequency of the drive. Okay, so first I will go online. It will take some time, not some time. Okay, then I will what is showing here. No, some issue is there. Okay, I think I should download wait, I will go there. Okay, so there's a issue there, some issue there. What is the issue? First I will download it. Wait a minute. Firstly go offline. Okay. Okay, I go there, I will download this. What could be the issue? Wait. Okay, so we will check what is the issue. We will download this. This issue came when some block or some module is not properly downloaded. Then we download it again. Okay, so load and finish, and now I'm going to online mode. Okay, so again some issue. Okay, I will check once. Okay, now everything is fine, because the issue was from the hardware side. The wiring get loosened. Okay, so I fix it. Okay, I check it. Okay, now I will go to my program. Okay, this is my program. Okay, now this is the okay, there is one thing also. This is the counter. So what is this counter doing? Okay, I use air clock pulse. After every second the counter value changes. Okay, so I use this output of this counter here, here, and here. I use all of these, and like I write here 2 value, I write here 1 value, I write here 0 value. And suppose I am using same MB master here. Okay, so what does this operator, you can say, it is doing, I want to change my value of the frequency. Okay, I want to change my frequency value. So there should be a condition like at the same time all these MB master cannot work simultaneously. Okay, so what these MB master is doing, these are updating the data. Okay, so at the same time we cannot use MB master same master address. Okay, so that's why all MB master operate at different time. I am using comparator here. Okay, so when the current value of counter is 0, then this will operate. When it is 1, then this will operate, and when it is 2, this will operate. Okay, so that's why I use this counter. Okay, now we will go to the monitoring mode. Okay, so in the monitoring mode our counter is started. You can check here our counter is running. Okay, now I will go there. So this is first scan. It will like a positive triggering pulse. Okay, so uh, now go. Okay, we came here. Okay, now at this address 48193, the value is 0 storing. Okay, so first I will set it to wait set it to 1. Yeah, the value 1 is reached there. Okay, now it is a no button, and the value reached there, and now my drive is stopped. Okay, now I check my frequency. My frequency at starting 0. Okay, so I'm adjusting it, like I'm changing it to I want to like 10 hertz at the starting. I want to raise my frequency to 100, but you can check my output frequency, it is still 0. Okay, so what I will do, I will run my drive in the forward direction. Okay, so 18 value will reach there, and you can check the output. Okay, output frequency is 100, that means 10. Okay, and same here 10. Okay, and my drive is running. I can also show you the drive. Okay, let's go. Okay, so here you can see the frequency standards, and the drive is in the run mode and in the forward direction. And when I click in the reverse direction, then this reverse button will it will blink. Okay, so now we have checked our frequency of the drive. Now we will rotate our drive in the reverse direction. Okay, now we will see what happened. uh, okay, for the reverse direction. Okay, so now we will rotate our drive in the reverse direction. So I will send this 34 value to my register address. Okay, so I will go there. The drive is running in the now in the reverse direction. Okay, so let's go to the drive and check whether it is in the reverse or not. Okay, and here you can check our you can see our drive is in the reverse mode. First it was in the forward, and currently the status is running. Okay, so let's go. Okay, so we have checked our the status of our drive, and everything like if any fault occur, you can reset this. Okay, and you can stop the drive. Okay, let's like I am stopping my drive, so I go there and go there, and like okay. So like if you want to ask me how do you know I will use the setting value, this is 34 value for reversing the drive. Okay, so let's come to the manual of the drive. Okay, okay, so this is our manual of the drive, and I will go at the page number where Modbus addresses are present. Okay, like here. Okay, like here. Okay, so it is given 48193, but I'm using holding register address, that's why I'm adding one. That's why I'm adding 14,001. I'm adding 48192 in 14,001, and that the holding register I'm using in my program. Okay, so like suppose I am this is the like I told you na ki that the data length is 1. Data length 1 means 16-bit data. Okay, so this is the our 16 bit data. Okay, so like I want to stop my drive, that means 2 raised to power 0, that means I have to provide one value there. So let's say program. Okay, like if I want to stop, then I use one value. Okay, like now if I want to start my drive. Okay, so if I want to start my drive, then I have to okay, start the drive, and also in the forward direction. So I am using the value to 2 raised to power 4 plus 2 raised to power 1. Okay, 2 raised to power 4, 2 raised to power 1. So it is 2 raised to power 4 means 16, and 2 raised to power 2 means 2. 16 plus 2, 18. Okay, so I am using here 18 value in the forward, and for the same for the reverse, and same for the fault reset value. Like we can go in the reverse. In the reverse, 2 raised to power 5 means 32, and 32 and start 32 and 2 34. Okay, so it is same. And for resetting, clear the fault, I am using 2 raised to power you can say 3. 2 raised to power 3 means 8, and here I am using 8. Okay, so I think you are clearly understanding the concept of the Modbus communication, and in the similar way you can perform the communication with the energy meter, and in same way you can understand the communication between the temperature controller. Okay, so next time we will do some different thing, like we will perform with the we will learn the wiring of the PLC. Okay, like how to do the supply wiring, how to do the input wiring using different type of sensors like PNP sensors and NPN sensors, and how to do the wiring related to the output module of the PLC. Okay, and we will also learn the analog input, using of the analog input and analog output. Okay, so we will discuss all this in the our next class. Okay, thank you.